Hello everyone, this is Subashri here. In today's video lecture, we are going to discuss about transistor biasing and stabilization. First of all, what is transistor biasing? The function of a transistor is actually an amplification process. So, what is amplification? The process of strengthening the weak signal without any change in its general shape, which is referred as faithful amplification. For a faithful amplification and also to make the transistor to act as an amplifier, the emitter base junction should be under forward biased state and the collector base junction should be under the reverse biased condition. So the proper zero signal collector current has to be maintained. So this is the major important aspect of transistor biasing. The proper flow of zero signal collector current and the maintenance of proper collector emitter voltage during the passage of signal is called as transistor biasing. Why biasing is very much important? If the transistor is not biased properly, then it may lead to distortion and it will not be working efficiently. And how the transistor can be biased? A transistor is biased either with the help of a battery or an associating a circuit with the transistor. The latter method is more efficient and it is frequently used. And the circuit which is used for transistor biasing is called as biasing circuit. And what is meant by bias stability? Through proper biasing, a desired Q point has to be considered. A desired Q point has to be found out in the active region of the transistor. Active region is what? A linear region of the characteristics which is being obtained. And it is desired that once selected the proper operating point, that it should remain stable. That is, we have to maintain the operating point stable is called as bias stabilization. And the selection of the proper quiescent point generally depends on the following factors. What are the two factors? Factor number one is the amplitude of the signal to be handled by the amplifier and distortion level in the signal, and the load to which the amplifier is to work for a corresponding supply voltage. These are all the two important factors which has to be considered. And the operating point of transistor amplifier shifts mainly with the changes in the temperature, since the transistor parameters, that is three values, beta, ICO and VBE, where the symbols carry their usual meaning. All these are the functions of temperature. And the DC operating point. For a transistor circuit to amplify, it must be properly biased with its DC voltages. The DC operating point between the saturation region and the cutoff region is called as Q point. So the goal is to set the Q point that it does not go into the saturation level, or it should not get into the cutoff region when the AC signal is applied. This is the constraint, or this is the condition for a operating point. And the requirements of the biasing network. First of all, we have to ensure that the proper zero signal collector current, as we already discussed, and ensuring the value of VCE is not falling below the 0.5 volt for germanium transistor and 1 volt for the silicon transistor at any instant, and ensuring the stabilization of the proper operating point, that is zero signal IC and VCE. And major important aspects of today's session is about thermal stability of an operating point. So what is thermal stability and what is meant by stability factor? The stability factor is as the change of the collector current with respect to the reverse saturation current, keeping the value of beta and VBE constant. That can be represented as S equal to, that is SIO, the thermal stability factor can be indicated by the term SICO, which is equivalent to dou IC by dou ICO, where the values of VBE and beta remains almost constant. This equation signifies that the value of collector current changes with respect to the IC naught times as fast as ICO. That is the point of this equation depicts. And the differentiating the collector current IC is equal to 1 plus beta ICO plus beta IB, and rearranging the terms to get that SICO, that is 1 plus beta divided by 1 minus beta into dou IB by dou IC, which can be noted that the value is lower than ICO, which can make the stabilization factor to be better. This is all about your today's thermal stability condition and today's topic. Thank you.